This is a video to go over lesson 3.3, which is about the derivatives of trigonometric functions. Okay, so we haven't talked really too much about trig functions yet. So I will just quickly do an introduction to them. Some of you will have seen them in Pre-Calc 12. So sine, cos, and tan are the main three. I'm just going to show you what their graphs look like, although you don't need to know how to graph these functions. You just have to be aware that they are functions and you have to know their derivatives. So for sine x, it looks like a wave, and cos x also looks like a wave, but it is just shifted over a little bit. And tan x looks kind of completely different. But the one thing that they all have in common is that they're periodic, so they repeat over and over and over again. Okay, the cool thing about their derivatives is that sine x and cos x are actually really closely related. So these three things you have to know. So the derivative of sine x is actually cos x. And the derivative of cos x is negative sine x. Okay. And the derivative of tan x is a little bit different. It is secant squared x. And if you are not familiar with secant, what this is just 1 over cos squared x. Those are the same things. Okay, so those are the three facts you actually have to know about trig functions. There are some basic identities that I'll give them to you on a test if they're required. Some of the textbook questions today are going to require that you know these, so you can just have these kind of by your side when you're working. These are not derivatives, they're just identities. So you can see tan x is the same as sine over cos, for example. Secant x, which we already mentioned, is 1 over cos x, etc. There's one more identity that you guys should know that I forgot to put on here, so I'll write it in. Sine squared x plus cos squared x equals 1. In addition, a little bit of something to note about, just put a note here with notation. People see this and get a little bit confused because they think, why is the sign, so why is the little squared not around the entire function? It is technically so. This is the same as this. It's just to avoid writing so many brackets, because sometimes you write a bracket around the x, and then if you had to bracket and then square everything, it's to avoid writing so many brackets. So when we square or have the different powers of sine, cos, and tan, we just write the power or the exponent next to the sine, cos, or tan, like that. Okay, so we're going to do a couple practice questions. It's going to be a super short lesson. We're just going to be practicing our quotient rules and product rules today with the trig functions. Okay, so let's have a look at this function here in part A that we want to take the derivative of. So we want to take the derivative of x sine x. Notice this is a product between x and sine x. So I'm just going to highlight the two parts. And we have to recall our product rule, which says that you take the derivative of the first function times the second function. So the derivative of x is 1. And then we just leave sine x plus we leave the first function and we multiply by the derivative of the second function. So we leave x as it is and we take the derivative of sine x, which is cos x, and we're done. I'm just going to rewrite that without the colors. So it'd be sine x plus x cos x. Okay, that's it. If you want, I kind of like to write little brackets around my x, but you don't have to. Okay. The next one says prove that the derivative of tan x equals secant squared x. So I already told you that this is true. It's written in the box above, but we're going to prove that it's true. So we are going to recall or just look at the little list above. Tan x is the same as sine x over cos x. That's listed in one of the identities above there. So d by dx tan x would equal d by dx of sine x over cos x. So we're going to take the derivative of this, and it is a quotient, so we're going to use the quotient rule. So I'm going to use my colors again. We have the numerator function and the denominator function. So first we take the derivative of the yellow, so it'd be cos x times the denominator, cos x, minus, so I'm just going to highlight. Now we leave the numerator as it is and multiply by the derivative of the denominator. So I have sine x times the derivative of cos x is negative sine x all over the denominator squared. And notice I used that notation where we put the exponent next to cos. Okay, and I'm just going to clean this up. So cos x times cos x is cos squared x. Sine x times sine x is sine squared x. And notice the two negatives there, so I'm going to change that to a plus sign all over cos squared x. And this, we can see above I wrote that sine squared plus cos squared x equals 1. And so I'm just going to write that in red. Recall that cos squared x plus sine squared x equals 1. So the numerator there is actually equal to 1. And 1 over cos squared x is secant squared x. So there we go. We just proved that it's true using color in my, there we go. The little colored in square at the end there, that just means end of proof. So if you're proving something and you want to sort of, it's like a period at the end of a sentence. Okay, so there's only 4 questions to do. Again, it's a really short section. We didn't learn any new derivative rules. We're just introducing 3 new functions, sine x, cos x, and tan x. And again, just to repeat myself, I will be giving you the trig identities on the test. You don't have to memorize those. Okay. All right, I'm going to end the recording.